File I/O in C and C++. In this section, we are going to talk about file I/O, how to read and write to files in both C and C++. Let's start with the definition. File I/O refers to processing and working with files. Storage of data in memory is temporary. So basically, most of our programs that we wrote so far, the data is being maintained in memory. The minute you exit your program, all the data is lost. Nothing is being stored in a permanent, persistent storage. So that's why we need to use files for data persistence, permanent retention of data. Programs that write to files use secondary storage devices such as hard disks, CDs, DVDs, and flash drives, as well as tapes. Even though the storage devices may be different, the way you can access them in C and C++ is going to be the same. You simply interact with files. So in this section, we are going to explore how to build C programs that can read, create, process data files. There are two ways to process files. First one is known as sequential file processing, and the second one is called random access. So the main difference is that sequential file processing is that you start by opening the file and then reading the bytes of data a chunk at a time and then processing them in your program. At the end, you need to close the file when you're done processing it. Random access, however, allows you to open a file and then access any byte inside the file in a non-sequential manner. You can just go find that specific byte by using some special functions to seek into the location where you need to read the data from. Think of it as an array by going into a specific location, a specific cell in that array. So that's the random access. In this section, we will be mostly looking at how we can work with files sequentially. What are the types of files that we need to learn about? The first type is called text files. A text file is a special case of a binary file. It's structured in a way such that it's easy for people to read it. It's human readable. So you have a sequence of lines of text. As a human, you can open it up in any editor program and you can look at it. Inside the text files, there are some special characters that we use, like end of line character, like we learned in C, the new line character. There's also an end of file marker, which designates the end of file. Once you hit the end of file marker, that means you have scanned through the whole file and you're done reading it. The second type is called binary files. A binary file is a file that is not a text file. The term binary file is often used to mean non-text file. Text file itself is a binary file, so in fact you can open up a text file as a binary and look at its data as a binary data, because at the end of the day the text is just a sequence of bytes, but we as humans, we can read it, so it gets displayed to us in a human readable fashion. Where on the other hand, binary files are not human readable. They will just look like garbage for you if you try to print them out. Okay, so how do we read and write to files? When we refer to reading files or inputting from files, that means that a file can be opened in read mode, which means that we can transfer the data from the hard disk, the storage it's being saved on, into memory of your program. That's known as reading from a file. Writing to file or outputting to file, in this case, what it means is that you take the contents of your memory program and try to store that into files. So you start streaming from the memory into the file. You can write to an existing file or you can create a new one. To show you that in a visual form, think of your program here as a program that has some data in memory, and this data is usually in binary format. And you want to try to write that data into a storage device like a hard disk. In that case, we open a file for writing and we just simply write the data into that file on some location in the storage device. Once you're done, you have to close the file just so that we can flush out any remaining data in memory buffers into disk and make sure we clear up everything that has been used in the process. The opposite is reading from a file. You start with the file and you start transferring the data, streaming the data into some memory blocks that are maintained by your program, and eventually your program gets to read the data and process it. In summary, Writing is taking the memory of your program into the storage device. Reading means taking the storage device data and reading that into buffers in your program. Now let's talk about how do we open a file. In C as well as C++, you can use the File Open API, and this is how it looks like. The File Open function takes in a file name and the mode you want to open it for. And the mode is used to tell the function whether you want to read from a file or write to a file, etc. The file name is a path string to the file on a storage device like a hard disk. Upon success, this function gives you back a file pointer. File is just a special type definition. Think of it as a void pointer. So once we have a pointer to a file, then we can use that pointer to call other functions for reading from the file or writing to the file and processing the file itself. The mode parameter can take one of the following values. If you specify R, that means open the file for reading. W will be opening the file for writing. In this case, the file need not exist. If you specify A as a parameter, in this case, you're open for appending, but also the file does not need to exist. When you say R+, that indicates that you want to open the file for both reading and writing. You can actually read from a file and write to the file at the same time. Also, you can specify W+, which means open for reading and writing, and this will overwrite files. So if the file exists, W+ will actually delete the existing file. Similarly, A+ means open the file for both reading and writing, append if file exists. So this means if the file exists, just don't delete it, start appending to the end of the file. Okay, now how do we read from a file? The first thing you need to remember is that you have the file open, now you need to read from the file. There's a function called FileGetC, which stands for FileGetCharacter. You give it the file pointer, that's why it's important to open a file, and then from that point on, you can read from the file as long as it has data. This returns an integer. That integer represents a single character from the file. In the case of ASCII, that integer is going to be from 0 to 255. So if you need to read one single character at a time, you use fgetc. Fread or file read simply allows you to read any size buffer from a file as long as the file has enough data to read. If your buffer is greater than the file itself, then this function returns the actual size that was read. So if you have a buffer of 1000 bytes and the file only has 500, it can only read 500 from the file and tell you that I only read 500. However, you still need to pass in the pointer to the buffer and the size of a single element in that buffer, as well as how many elements in that buffer. 1000 bytes, we would say this is the pointer to buffer. It's going to be 1 byte each element, and the count is 1000. The last parameter here is the file pointer that you want to read from. There's also a scanf function version that works with files. It's called FileScanf. And this one, you can give it the file pointer and a format string if you want to read one integer at a time, one string at a time, in any format you want, then you can use this. And then there's also FileGetString. It reads from the file one line at a time. This is useful for text files. Next, we talk about writing to a file. File put character. You give it a character or an integer and you can store that in a file. This is when you want to start writing some data into the file. There's file write, and this one allows you to actually write to a file a number of elements. So this is useful for writing large chunks of data into the file. Also, there's a printf function for files. It's called fileprintf. The main difference is that the first parameter is a file pointer, and you just use the same formatted string output. This might be useful for writing to log files. If you want to create your own logging mechanism by using files to log data into, then fileprintf might be a good candidate to use there. Let's talk about the end of file marker. Do we have functions to tell us if we are at the end of file marker? Yes, there are some functions. One is called file end of file. So what does it return? If it returns 0, that means no, it's not the end of file. Any value that's non-zero, that means it's an end of file. There's also a file error function that can be useful to indicate what kind of errors we encountered as we were trying to access or process a file. So you give it the file pointer. This will give you back an error value, and you have to look up documentation on this to understand what are the possible return values here. Every time you access a file, whether you're reading it or writing to it, you must always close the file. Failing to close a file can result in unpredictable behavior or some loss of data, because sometimes the data is still in memory and it hasn't been flushed out to the file. In the case of writing, failing to close the file, you might not flush out any remaining data in memory into the file, causing some data corruption or loss of data. In the case of reading files, if you forget to close a file, that might cause memory leaks by not clearing up any of the resources used during the process of opening and accessing the file. Always remember to close the files. In C and C++, we use fclose function and give it the pointer to the file so that it closes the file. That's all I wanted to talk about in this introductory lecture about the files. In the next lecture, let's look at how we can actually use some of these functions to read from files and to write to files. So see you in the next lecture. File I/O, reading a file in C and C++. In this lecture, we're going to learn how to open a file for reading and start reading data from that file. As a reminder from previous lecture, we said we want to open the file using the FileOpen function. We give it the file name and the mode we want to use. In this case, since we're reading, we're going to use the R mode. R means read, open file for input operations. The file must exist. So in order to do that, we have to find an existing file or create a file manually so that we can read it into our program. So let's jump right into Visual Studio to see how we can do that. Okay, so here I am in Visual Studio. Let's create a new project. Click on File, New Project, and make sure you have Visual C++ 132 selected. Click on Console Application. And let's call this read file. Click OK. Here we want to click Next. Make sure on this page you have empty project selected, then click Finish. Let's add our main.c, right click on source files, add new item. Then let's call it main.c, click add. Okay, in this lecture we want to see how we can read a text file and then print it out on the command line. We can either hardcode the file name here, or we can simply allow the user to pass it in as an argument. So we can say integer argc, count of arguments, and a char pointer argv, an array of parameters that are passed in from the command line. So basically what we want to do is we want to be able to allow the user to specify a file name on the command line, and then we print it out. Using the file operations, we're going to first open the file, then keep reading from it until we hit the end of file marker, then we close the file and we terminate the program. Our program is called read file, so it's going to be readfile.exe, and then they have to pass in a file name to be printed out. So that means we have two arguments on the command line. We're going to check the argument count. If argc is not 2, we simply tell the user printf usage is readfile.exe followed by a file name, and then we return from here. So now this is basically telling the user that we need to have them pass in the file name. The first thing we want to do now is open the file. We're going to need to open the file for reading. So we're going to declare file pointer fp equals fopen. As you can see here, it takes in a file name and the mode. So the first argument is the file name, which is argv of 1. Remember that the arg count is 0 based, so the first argv of 0 is the readfile.exe, argv of 1 is going to be the file name. So we're going to open this file in a read mode. This means that the file needs to be an existing one. If the file open function cannot open the file, it will return back a null pointer. So we need to check if null is fp, then we have an error here. It's always good practice to check for nulls and to check for errors when dealing with files. So we're going to say here printf failed to open %s, which is the file name we have here. Okay, and then return because we cannot continue. Otherwise we have a file pointer. Next we wanted to read from the file as long as it has data, so meaning not in the file. So how do we do that? We need to loop. We need to say while not file end of file, the file pointer we have. As long as it's not the end of file, we keep on reading. So I'm gonna say integer c equals FileGetC. So that's the first function we want to use here. We're going to read one character at a time. Then we simply say printf %c and just give it the c character. Okay, so this way we keep looping until we read all the data from the file one character at a time. And once we're done, we must close the file. And that's done by using fclose and give it the file pointer. And it's a good practice after the file close to set file pointer to null so that we don't accidentally try to use it after this point. Once the file is closed, we cannot read from it, we cannot write to it. So that's how we simply are going to read the file by opening the file in read mode, check for errors, and keep looping until the file in the file returns true. In that case, we break out of the loop. And then lastly, we close the file. So let's compile this, Ctrl+Shift+B. I'm getting an error here. It says the file open is not safe. Consider using file open _s. We can either call file open safe, or we can simply say define CRT secure no warnings. Do not warn me for insecure functions. Let's for now just do this. At the very top here, we can say define _CRT secure no warnings. In that case, do not fail on using file open. Let's compile again, Ctrl+Shift+B. Alright, so we're successfully here creating readfile.exe. I'm going now to copy this path because I want to go there to show you how we can use this. So right click, copy, and then I'm going to launch a command window. I'm going to click on window R. This will launch the Run Dialog. I'm going to say here CMD to launch the command window. I have the command window here. I'm going to CD into the path that I just copied. CD into this path, right click once, and take out the file name because I want to go into the directory, not the file name. Like this. So now if I say dir, you can see here I have my read file exe file. If I try to run it now, hit enter, it's gonna show me usage readfile.exe file name because we need to pass a file name. So ideally we want to say like my file.text, something like this. As you can see now it says fail to open my file.txt. Well, because we don't yet have a file called my file.txt. Let's create one. You can say notepad my file.txt. It will create a file here. Hit enter. This launches notepad and it asks you, do you want to create a new file? Yes. Now let's start typing. This is my file that I created manually using notepad.exe. You can say working with files in C, C++ is fun. I am learning to read and write files in C, C++, and I think this is going to be useful for my future apps. This is the end of the file. You can type whatever text you want. I just wanted to show you how we can just simply create a file. So now when I save and exit, I should see that file. If I say again now dir, you should see my file.txt here. It's got 240 bytes. That's what we typed. So now we can say read file, my file.txt. And now as you can see, the program actually was able to successfully read the file and print it out on the screen here. So this is the content of the file. So the last of it was the dot, and then after that is the end of file marker. So we're done reading the whole file. Okay, so back to Visual Studio. As you can see now, this is how we read the file. One thing we can do is we can be creative. Let's add a space here. I'm adding a space, an extra space here after every character. Let's compile this, Ctrl+Shift+B. Let's go back to that command window here. And let me clear the screen, CLS. I'm gonna say read file, my file.txt, and hit enter. Now as you can see, after each character, we're actually injecting a space, making it look kinda too spacey. Okay, so what else we can do here? We can actually see the characters as binary, or as, let's start as decimal, %d. If we do it as %d, Ctrl+Shift+B to compile, and then go back to that command window, CLS again, and then I'm going to say read file, my file.txt. Now, as you can see, it's spitting out every character in its decimal values. To show you how like binary file readers display output, they usually do something like this: %x or %02x, because we want it to be 2 digits in hexadecimal, and we want it to be also 0 padding, means that if it's only one character, it will start with a 0. If you do capital X, everything will be capitalized. Let's do this: 02x. Control Shift P. Compiled successfully. Let's go back to the command window and clear the screen again and run this command. And now, as you can see, everything is being displayed as hexadecimal. That's the content of the file being displayed as all hexadecimal. Alright, so in this lecture we learned how to open a file for reading and then how we can actually print it out on the screen. In the next lecture, let's see how we can use another function to read the data from the file. In addition to fgetC, we said there's fread, there's fgetString, which reads a line at a time. So see you in the next lecture. In the previous lecture, we learned how to use the file functions to open a file with fopen, and then after that, check for errors, and then read from the file as long as we have content, get one character at a time, and print it out on the screen. This was %C to display the content. Okay, so today we want to make an improvement here. I don't want to read one single character at a time. What if I want to read more than that? Let's say I have a buffer here, a char buffer of 1000 bytes. I want to read 1000 bytes at a time. In that case, I can simply say file read, and this takes in the buffer that we have. The size of each element in this case is 1, and the number of elements is 1000. Then the last argument is the file pointer I want to read from. This gives you back a size t count, which tells you how many has been read so far. Let's say if count is less than 1, then we want to break out of this loop. Otherwise, we're going to say buffer of count equals null termination. This is how we basically null terminate the string. And then we can say now printf %s the buffer. So this is basically an idea where we can read more than just 1 byte at a time. In this case, the whole file is going to be read one time. Our file here that we want to read is called my file.txt, only has 240 bytes in it. So in fact, this loop is going to only execute once because we have a buffer that's bigger than the file size. We're going to read the whole thing into memory once, display it out here. So let's compile this, Ctrl Shift B. Okay, this is compiling fine. Let's go back to our command window, and I'm going to say now read file, my file.txt. If you have noticed, there's no difference in execution here because simply it's the same output. The only difference is that we were able here to read the whole file once. Alright, so the next function we want to use is called FileGetString. Takes in the buffer and the maximum count in this case, which is the size of the buffer. I typically like to do size of buffer divided by size of buffer of 0. This gives you the count or the size. Why this is more useful? Because this allows you to go back and change the buffer without having to change the same number here. This way you just rely on the fact that you let the compiler figure out this value for you. Okay, so now if this returns null, either we don't have any more data or something went wrong, but we can break at that point. The other difference is that FileGetString will actually return if it finds the end of line character. Okay, let's try it now with the FileGetString. So hit Ctrl Shift B on the keyboard. Okay, it's compiling fine. I'm gonna go back here, clear the screen, and then run it again. And as you can see, it's also displaying the same data here. But the other difference may be that we can just display here. Let's have a counter here to just figure out how this is working. Integer index equals 0. And then we can display here %d between brackets like this. I'm gonna put here index ++. And the reason I'm doing this, I just want to show you how the get string, if it actually does one read at a time, or if it actually breaks it down by line number. So Ctrl+Shift+B, and go back to our console application, run this one more time. And now, as you can see here, it's actually getting back from the file each separate line. And that's where it could be useful, where, for example, you want to show the line numbers here, right? Line 0, or maybe you shouldn't start with 0, start with 1, but the idea is the same, is that FileGetString will read a single line at a time. That's where it could be more useful in situations like this. If you want to display the output along with the line numbers, you get that much easier than dealing with file read or FileGetCharacter. So depending on the situation, you could pick and choose which function to call. Okay, so that's it for this lecture. See you on the next lecture. Writing to a file in C and C++. In this lecture, we will see how we can read from a file and then write the content into another file using the functions that we learned about in previous lectures. So let's jump into Visual Studio and get started. Here I am in Visual Studio. Let's click on File, New Project, and make sure, as usual, you have the Visual C++ 132 selected, and click on Console Application. I'm gonna name this one CAD File. You can see its name is CAD File. Click OK. On this dialog, click Next. Now make sure you select Empty Project and then uncheck the Security Development Lifecycle. Let's go ahead and create our main.c. Right click on Source Files, Add New Item. And let's type main.c here and then click Add. Okay, in this lecture, we want to see how we can read data from a file and then copy that into another file. However, we want to make it more interesting. Instead of just blindly reading and writing, we are going to call this CAD file, where it will get all the content from file 1 and then output that to a file that has everything as capital letters. So let's see how we can do that. Instead of hard coding the file names, I'm gonna utilize the command line arguments. So define integer argc and then char pointer argv array. First thing we want to do is check if the arg count is not 3. Then we will need to tell the user how to use this program. We say capfile.exe, infile, and then outfile. They need to understand how to use our program. Then we simply return here. So the next thing I'm going to do is I'm just going to define two variables, char pointer p infile equals argv of 1, and then char pointer p outfile equals argv of 2. So basically, this is argument 0, this is argument 1, this is argument 2. We want to know the name of the input file and the name of the output file. First thing we want to do is open files. We will open one of the files, the N file, in read mode, and the output file, we're going to open it in write mode. So as a reminder, when we open the files, we use the R mode for the files we want to read from. The file must exist. That means the input file must exist. And the file that we want to create, we will use W. This creates an empty file for output operations. If a file with the same name already exists, its contents is going to be discarded. That means the file will be deleted. So make sure that the output file name is not an existing file, otherwise we lose an existing file. So if you want to be careful and not delete existing files, then you might want to check first if the file already exists or not. But we're not going to cover that in this lecture. Maybe in future lectures we can discuss that. But for now, we're just going to use the read mode for the in file and the write mode for the output file. Okay, so let's switch back to Visual Studio. Alright, so I'm going to define a file pointer, file fpr equals file open. The name is pinfile, that has the name, and then we're going to make it as a read mode. We should always check if we got a null back here or not. If file pointer to the file that we want to read is null, then we say printf failed to open this file. And then we simply have to return. Okay, so I'm going to copy the same code here because we want to do it again for the file we want to open for write. I'm just copying it and changing the name to fbw. And also this is going to be the out file, and we're going to open that for writing, not for reading. If we can't open it for writing, then we can say failed to create the file called the out file. In case we can't open the output file, we need to let the user know that we failed to create the file. The main difference between this code block and the one before is that at this point, we know that the file we want to open for read is already open. In the event we fail to create the output file, if we just simply return here, then we actually end up in a case where we have opened the input file but returned without closing it. So the proper way to do this is to actually also close the file open for read. So this is how we open the two files. At this point here, what we want to do next is we will read all content from file 1, which is file open for read, and then convert to uppercase, then write it to file 2, which is the file open for write. That's what we want to do here. We will continue to read everything from file 1. That means while not file end of file, file open for read, we are going to do the following. We're going to say integer c equals file get character from file open for read. Now that we read the byte out of the read file, we're going to say file put character c into the file open for write. That's basically how we do it. And at the end, once we're done, we have to close both files. And it doesn't matter in which order you close them. You just need to close both files. This is how we basically implement this. There's one thing missing. Right now, we simply just copy everything from the input file to the output file. We said we want to make it all capital. So a step here is missing, which is to call toUpper function on this character. In order for us to use the toUpper, it's defined inside a header file called include ctype.h. This file is used for toUpper function. And you don't have to memorize this. If you don't remember, you can Google it. You can also hit F1 key on the keyboard. It will open up MSDN for you and it will help you find the function you want to use. Okay, so this should be pretty much it. Let's give this a try. Let's compile it first. Ctrl+Shift+B. So if you remember in this project, we actually unchecked the deprecate unsafe functions. The main difference between this and previous projects we created is that in this case, we're only getting a warning here. We're not getting an error. Previously, if we kept that box checked, we would fail to generate an exe. In this case, we're not failing. It's just warning you that this is a warning, this is a warning, and we still get our exe file generated. However, if you don't like this warning as well, you can just suppress it by defining this macro. Just gonna take this and put it here at the top. Define this macro. That way we get rid of the warnings. I usually don't like to see any warnings in my output. Okay, so now we're successfully building. Okay, now in order to call this from the command line, I'm going to copy the full path here. Right click, then copy, and then I'm gonna launch a command window. Hit Command R on the keyboard, type cmd. Then I'm gonna cd into this folder, dir. This is where our CAD file is. If we try it out now, CAD file exe, it says CAD file needs input file and output file. Okay, so let's manually create an input file. Notepad, let's call it test.txt. Yes, let's create one. This file is a test to be used with our CAD file program. This is the second line. This is the third line. Then finally we can say working with files in C and C++ is always fun. Bye now and dot. So I just created a file. You can create your own file. I'm gonna make sure it's saved. So click on save and then exit from here. Now I should see if I say dir, if I list the directory, I should see the test.txt in here. Okay, so now let's give this a try. CAD file test.txt, and then let's give it out.txt as the name. All right, this program doesn't print anything out on the screen. Let's dir again. And as you can see, we have created the out.txt. So let's view out.txt, notepad out.txt. And as you can see, everything is now capital letter. However, we have this weird character at the end. I think our code has a bug. Let's go back and see why we have a bug and how we can fix it. So going back to Visual Studio, as you can see here, basically we're doing a while loop while the file in the file is not FBR. Then we get something from the file, turn it to upper, put it into the output file. What causes the file to reach end of file is this function. This function actually, as it gets to the last character, the next time it reads, it will hit the end of file character, and that's what it returns. It can sometimes, if you read the documentation on this function, return the end of file here. And that's when you go back and check here. That's when you get out of this loop. That's when we break out of this loop. And then after that, file end of file verifies that the pointer is at the end of file, and then it exits out of the loop. However, before we do that, we just take the end of file, make it upper, and try to write it to our output file. And that's what's happening here. So to fix this bug, we need to say if not in the file is the character, in that case, we only put it to the output file. We don't want to write the end of file character into the output file. So this is going to fix that issue. So let's compile this, Ctrl+Shift+B, make sure we have a successful new exe. Okay, we successfully built an exe. I'm gonna go back to my command line and let me clean the screen. I'm gonna say dir. Notice that our output file was actually 1 byte extra than the input file. So now let's run this again, CAD File, test.txt, and then say out.txt. Let's dir again. Now you can see both files actually have the same size, which means we have fixed the bug. Let's open output.txt, notepad, out.txt. And now as you can see, everything is the same as the input, with the exception that everything has been capitalized. This is one example how we can read a file and write it to another file. You can continue practicing with the file API yourself. You can try out many examples of maybe counting the number of words in a file, making only the first letter of every word capital and everything else lowercase. That would be another exercise. You can also put a list of numbers in a file, read them, and find the average number inside the list, or maybe sort them out. Now that you understand files, you can easily build games or applications that can persist data using these APIs. That's it for this lecture. See you in the next lecture. File.io. In this lecture, we will look at how to implement a cool utility called Color in File. So let's jump into Visual Studio. Here I am in Visual Studio. Let's go ahead and create a new project. Click on File, New Project. Make sure you have Visual C++ 132 selected, then select 132 console application. I'm going to call this application Color in File. Okay, click OK. On this page, click Next. Make sure you have Empty Project selected and then uncheck Security Development Lifecycle SDL checks. Then click Finish. Let's add our main.c file. Right-click on Source Files, add New Item, and let's call it main.c. Then click Add. In this lecture, we want to see how we can search some text in a file and then display it on the output in the console window. We're only going to highlight or color the text that the user is looking for. So in order to do that, we're going to need to define the argc here and then the char pointer argv. Okay, so the assumption is that the user is going to pass us two parameters, the file name to search in and the text to search for. So let's make sure that the user is aware of how to use it. So we say if argc is not 3, we're going to printf usage is color in file, text search for, and then the file name. So based on this, we have the file name is the first argument, and then this is number 2, this is number 3. That's why we need 3 arguments. I'm going to define some variables here. Char pointer keyword to match equals argv of 1, and then char pointer p file equals argv of 2. Let's figure out the length of our string. Len equals strlen of the p word to match. So the first thing we want to do next is to open the file for read. So file pointer fp equals file open pointer to file name in the read mode. We have to check if this was successful or not. If null is file pointer, then we have to tell the user this is something is wrong with that file. Fail to open your file with the name p file. Then we have to return from here. Okay, so now that we have the file open, we're going to read out the content of the file. So while not file in the file fp, we're going to define an integer c here equals file get character from the file pointer. And as we learned from previous lectures, if in the file is this character c, we can break out of this loop. Otherwise, we're going to print out the character here. Then at the very end, once we're done, we have to close the file. And it's a good practice to say fp equals null, set it to null so that we don't add any future code to use it after it's been closed. This is the main logic of the code. Now we want to add some special handling here for searching for that string. Let's find the string to match. The simplest way to do this, if C is actually the first character of our word to match, keyword match of 0, if this is the same as C, then that means we have found the beginning of a word that most likely is going to be a match of our word. So what I'm going to do next, I'm going to read the whole word into a text buffer and then compare it to our string and decide if it's equal. Then we're going to print it out in a special color. Otherwise, we just print it out in a normal color and continue. So let's define a temp buffer here. Char word of maybe a maximum of 1,000 characters. And then integer index equals 0. So I'm going to do the following: do while f in the file, and maybe some other conditions in here. Basically, what I want to do is I want to keep reading word of index ++ equals C. Cache it, and then C equals fget C, get the next character from the file, while not in the file, and index is less than len, because if we still read and we know that the word to match has a specific length, if we continue to read past that length, then we know that this is not a good match. Okay, and then what else? We want to say also and index is also less than 1,000 because we don't want to go past the 1,000. Then we should be safe this way. Okay, so basically what we're doing here is that if we find the character we just read from the file matches the first letter of the word we're looking for, or the first character, so what we want to do next is basically try to read the remaining characters inside the same word from the file and cache them into a temp buffer called word in here. So I'm assuming it's 1,000 maximum. If you have words more than 1,000, you can actually optimize this code further by either increasing the size here or dynamically allocating the memory based on the length. So I would say maybe a better approach is to come here and use malloc to create a temp buffer that's the same length plus 1 character for the null as the word that we're looking for. But just so the code doesn't get more complex than it needs to be, I'm just going to use a hard-coded size of 1,000. Okay, so what I'm doing here is looping through, getting a character at a time from the file, and then inserting them into this temporary buffer at the next location while the following conditions are true. We're not at the end of file, and the index that we incremented is still less than the length, because if the word we're looking for is 10 characters, we don't want to read like 15 or 20 characters. We should stop at 10. And at the same time, the worst case, if the index is larger than 1,000, then we should stop. In any case, when we exit here, what we want to do next is to null terminate the string. So we can say here 0 termination at this index, because we always increment the index. We know that this is the correct location here. All right, so now we can verify that the number of characters we read from the file and the word we're looking for are identical. And we do that by using string compare function. So it takes 2 parameters, word and p-word to match, should be good enough. This will return 0 if they are identical. Notice that this function is case sensitive. If you want it to be insensitive, you just use the string insensitive compare. In my case, I just want it to be case sensitive. So this is enough. What do we do next if this is a match? What I want to do actually is I want to be able to print this word out in a different color. And to do that, I'm going to use a Windows specific function to change the color on the console. For that, I'm going to need to include windows.h. So I'm going to include here windows.h header, and then I'm going to go back and use the function. There's a console function called set console text attribute. This is the one. This function needs the standard output handle. The way to get it, we can say get standard handle, and we give it a parameter standard output handle. So that's the first parameter. The second parameter is the color attribute you want to use. In this case, I'm going to just use the color 206, and you can experiment with any color you want. So now we change the color of the text. Next, using printf, we can print the word that we just found. And to make sure that we return the color of the text to its previous state, we have to call this again and use the previous color here, 15. The better way to do it is to actually, before we do this, is to get the current color from the standard console output and keep it in a variable, change the color, and then set back again the old previous value. But I'm not going to do that because it's going to also make the code more complex. Let's just keep it simple here. Okay, so basically what we're doing here is we're printing out the word in a special color if this was a match. Else, if this was not a match, you can just simply print the word. In both cases, we have to print out the word that we just read from the file. So I think this is pretty much it. Now let's compile, make sure we have no compilation errors, and then after that we should test it out. So Ctrl+Shift+B to compile. Again, it's warning me that the fopen is an unsafe function, and we've learned that we can just simply deprecate this by using this definition. So go back here up, hash define this macro, Ctrl+Shift+B to compile again. Okay, so now I have successfully compiled. So I'm gonna use this on the command line. So the way to do it, I'm gonna just copy this path. Now I'm gonna launch a console window by hitting the window key with the R letter, which stands for run, and then type cmd. Now I'm in the console window. I'm gonna cd into the directory of the executable we have, cd and the name of the directory. If I say dir here, I should find my color in file exe. So let's try it out first with no parameters. It should show us that usage is color in file, text to search, and the file name. Since we don't have a file to search here, let's create one. Let's say notepad test.txt. You want to create a new one? Yes. I'm going to actually go back to Visual Studio and just copy this code, hit Ctrl+A on the keyboard, right click and copy, and then go back to Notepad, paste the code here. Just for fun, I'm going to search my code itself. Okay, save it and close it. Now we go back to the console window. If I do dir again, I should see test.txt. And if you want to type it, we can say type test.txt, and it has our file that we just copied here. Okay, now let's try out our application. Color in file. Let's look for the word itself inside test.txt. As you can see now, we were searching for the word in our file, and it successfully showed us all the words highlighted in the color that we specified. We can try some other cases. Let's say look for printf. Okay, now you can see it's highlighting printf for me. In fact, I think the code is smart enough. Even if we just look for print without printf, you can see it's now highlighting print without the F letter. What else we can try? We can try even single letters. Let's try a single letter. Let's see what is the most common here. F letter is the most common in here. As you can see now, it's highlighting the letter F everywhere. So once it's highlighted, you can easily count it. You can easily find it. So that's it for this lecture. See you in the next lecture.